뭐야? 2단계는 어떻게 갔지? 1.1강 말고 2단계는 어떻게 갔지? 바로 연동이 됐으면 좋을 것 같은데. 찾았다. 1.2강 차량의 동력 만들기. 오케이.
Now watch and pay attention before you do this yourself. We have our layout set up nicely here in Unity, so everything is nice and organized. We have our scene set up. So now we're actually going to create our very first C# script to be able to control this vehicle's movement. In order to do that, we're going to go to our project window, and then make sure you right-click on the Assets folder. And then you're going to go to the Create button, and we're going to create a new folder. We're going to name this folder Scripts, because this will actually be holding all of the scripts that we'll use to manage all of the interactions in our game. Now, it's very important, especially as you start a project, to keep all of your different folders organized, so that way it's easier to find all of the different things that you need, whether it's your assets that you're using in your scene, like in our course library, or different scenes that we need to manage, or in this case, our scripts, so that way we know where all of our programming is being done. Now, what we're going to do, we're going to make sure it gets added to the scripts folder, so we right-click over our scripts folder, and we create a C# script. Now we're going to name this script Player Controller, capital P, Player, capital C, no spaces, Controller. Now, when we press Enter, Unity will automatically create this script for us, and we can actually preview it on the side. So you might be wondering to yourself, why did we capitalize the P and the C, and why are there no spaces? Well, this is actually something called a naming convention, and this is just a standard thing that developers do and people do when they're creating their projects as a way to make it easier for other people to jump into somebody else's project. So if somebody were to play around in your Unity project, they could understand the scripts and all the things that they're supposed to do and what they are. So capital letters for each word in a script makes it really easy for people to know that what you have is a script right there. Another reason to name scripts up front is because it can actually create a pretty large problem in Unity. So what I'm going to do is on my scripts folder, if I right-click on it and I click Create C# script, and I don't know what to name this script for now, so I'm just going to call it Test. And so here you can see that the test script is created, and you can see that it's previewed over in the inspector. Now, say later down the line, I want this to do something. I don't know, maybe for some reason I want to make the obstacle fly or something like that. And then I press Enter. So we've renamed this script to be obstacle fly, but in our inspector, you can see the preview of our script. It's still called test, even though we just changed it. So this could actually potentially break things in your project and create conflicts between the name of what you have in Unity and the name of your script. And so it's just better to name everything up front, name it exactly what you want it to do, and make sure that you use the standard naming convention, so that way it's easier if other people have to jump into your projects. So I'm going to just right-click on obstacle fly, and I'm going to delete this from my scripts folder because we don't need it. So we have our player controller script now, and we're going to left-click and drag it onto our vehicle. And now, if I click on my vehicle, you should see on the right side in the inspector that there's a player controller script that's been added to our vehicle. Now, scripts are the way that we're going to actually create all of these different interactions for any of our obstacles, our vehicles, even our camera in our environment. And so when we want something to do something, we need to use scripts to be able to tell Unity what we want that thing to do. In this case, our player controller script will make it so we can actually move our vehicle and control it. In addition, when we dragged our player controller script onto our vehicle, you can see that it was added here in the inspector, and so it was added to our list of different components. And so our components are basically the different properties that we can see attached to all of the objects in our scene. So, for example, our vehicle has our transform, so it can control the position in the world, how it's rotated and oriented, the scale. We added our player controller script, so we know that we're going to create a behavior for this vehicle. And then there's other things too, like mesh renderers and mesh colliders, both of which we'll get into later. A mesh renderer just helps to actually enable Unity to show you the vehicle with all of these textures applied onto it. And the collider will actually be something we use later so that we can have our vehicle run into our obstacle. Now, for example, if we went onto our obstacle and we accidentally added our player controller, which we can also do by left-clicking and dragging onto our inspector if the selected object is highlighted, we can add it that way, but I don't want the player controller on this obstacle, so I can click this gear icon next to it, and we can actually remove that component. Or if I wanted to add a component another way, I could also click the Add Component button, and you can actually see all the different components that you could use if you ever wanted to, or you can just type in the name, so we have that player controller, added it there, but we don't want it on our obstacle at all, so we're just going to click on the gear, remove that specific component, and we're good to go. So what you're going to do is you're going to right-click on your Assets folder, create a new folder, name that folder Scripts, so that way we can see where all of our scripts in our game are being managed and organized. On the Scripts folder, you're going to right-click directly onto it and create a C# script, which you will name Player Controller, capital P, no space, capital C, and then you're going to add the player controller script either by left-clicking and dragging it and dropping it onto our vehicle, or if you select the vehicle by clicking on it, you'll see it pop open in the inspector. You can left-click and drag the player controller into the list of components, or if you have your vehicle selected, you can click on the Add Component button. You can type in the search bar and type in Player, and that'll pop open your player controller script that you can see here, and you can add it that way. Now it's your turn.
오케이. 이렇게 시작 스크립트가 어떻게 추가되는지 봤다.
We've created a scripts folder and we've created our first C# script and we've applied it to our vehicle as a component. And now we're actually going to get familiar with our script and the structure of it before we write any of our code inside of it. So make sure that in your assets folder you have it expanded, and then you open up your scripts folder by expanding it. And then if you double click on the player controller script, now you can see that my script has opened up in my IDE, which stands for an Integrated Development Environment. And basically, an IDE enables us to actually interact with our code and write lines of code and text inside of it. So you can actually see there's words that you would be very familiar with, like words like using and public and class. And so very similar to how you would write a note or write an essay in a text document, our IDEs enable us to actually write for our programs. So I'm just going to clean mine up a little bit. There's a whole bunch of information here that's not entirely necessary, so I'm actually going to go on my IDE, close this little Solution Explorer. I don't really need that. I don't need the Team Explorer either. I don't need the properties. Cool, so now I have a full screen. I'm going to make this a little bit larger. It's just a little hard to see. So on the bottom left, I have this little zoom option, so I'll set this to 200. It's pretty good. Now, my IDE is set to Visual Studio. That's actually the default that you would get downloaded on Unity. If not, you can always go to the website to go download Visual Studio from Microsoft. You might also notice that some of the colors are very different. Maybe you have a white background. That's just a setting of mine. I just turned my settings to be a dark background. I use some different colors for words because it helps make it easier for me to see. So you can change those settings on your own, or if you're using a different IDE, then you should be able to customize it in your own ways. But if you download Unity for the first time, you will download Visual Studio. Now, if we take a look at our class, I mentioned it before, but you can see all these words that are very familiar to you. Words like using, words like public and class. And a really helpful thing about an IDE is that in my case, it actually highlights certain words that are very important for a person and a computer to understand. So the different words that are actually highlighted in blue are standard keywords that your computer is made to understand. With our script itself, our player controller, you can see the name that we made before. And in fact, there's this weird colon icon. And so that icon actually means that this player controller inherits from another class called MonoBehavior. And MonoBehavior is actually a class that's applied to all the different objects that we create. So actually, if we made a script for our obstacle, it would also use things from MonoBehavior. And that's very helpful because in MonoBehavior, a lot of different things that we would need to write ourselves are already made in Unity. So it's really helpful and really easy to get started. For example, we have these two methods here, and you can tell they're methods because they have the word void, and then they have these parentheses, and then they have these curly brackets. So this usually tells you that this is a method statement. And here's actually where we can go write in some code if we wanted to. So start is a method that, as you can see, actually has a comment up here that is called before the first frame update. So when you press play on your game, it would call the start method. Versus the update method, another method from monobehavior. And update is called once per frame. So this is actually constantly checking in your game for different calculations it should make, or different things that it should be checking against if you have a box that collides with something else or something like that. And the difference here, you can see, so these two forward slash marks actually create a comment, and your computer will not read what is on this line of code. So comments are for the purpose of a person to understand what they're reading inside of a method, versus the methods are actually the pieces of information that your computer needs to run certain tasks. So now, in our update method, we're going to write our very own comment. So make sure that you have your text selection inside of the update method. And then if you write / 2 forward slash marks, we can say, we'll move the vehicle forward. And so now this is where we're going to write our line of code to move the vehicle forward. But for now, we're just going to make a note for ourselves that this is where we're going to do it. So what you're going to do is you're going to double click on your player controller script. And then your player controller script should open in the Integrated Development Environment, or IDE, that was set by Unity. And then in your player controller script, down in this section of code here, right after public class player controller, you can see all of the different methods that are automatically added by Unity. And specifically in our update method, we'll write a comment using 2 forward slash marks so that we can tell ourselves that this is where we'll write code to move the vehicle forward. Now it's your turn.
오케이. 그래서 키는 방법, 아이디 연결해서 하는 걸 봤고, 여기서는 주석을 추가했으니 차량을 실제로
We've opened up
전진하는 걸
our player
도와준다.
controller script, and so now we can see all of this code that's inside of the script. And so we'll actually write our own line of code so that we can make the vehicle move forward from our little note we made for ourselves before. Make sure you pay attention before you do this. So what we're going to do is we're going to write our very first line of code here in our update method. So if I select this text block right after the word forward, if I press enter, so this creates a new line. So in programming, a blank space doesn't matter. Our computer just knows that there's nothing there. And what we're going to do is we're going to program using a programming language called C#. So everything that's done in Unity uses C#. If you're going to make a mobile application, or if you're going to make a website, there are other languages that you can use to create those different kinds of applications. But for our game, we use C#. And C# is just one way that we're able to communicate directly with our computer using certain words that a computer is able to understand to do something that we want it to do. So in this case, we're going to write a line of code to move our vehicle. Now, what I'm going to do is I want to help visualize moving this vehicle down the road. So if I actually select the vehicle in my project hierarchy, so now you can see it's selected. If I left click on this blue arrow, I want to move the vehicle down the road. You can see down in the game screen. That's exactly what I'm trying to do. In fact, if you look in the inspector on the right side, as I'm moving this blue arrow in our transform component, you can see that the Z is actually updating. And so that gives us a really good hint of what we're trying to accomplish. So if you remember, our transform component was the thing that was updating as we moved that vehicle in the scene. In fact, we can actually use the transform component directly. So if I just type in transform, and in this case, lowercase versus capital case T is extremely important. They're two very different things. The transform is actually an entire class, very similar to our player controller class that has even more methods inside of it. A lowercase t means we're getting the transform component of our current object. In this case, it's going to be our vehicle. So now that we're getting our vehicle's transform, what we actually want to do is we want to move that vehicle in that Z direction. So we can use a method using a dot. So a dot will help us get methods out of our different classes and objects. So dot translate. And so you can see here this is a capital T because this is a method just like our update method. And so what is happening here is we're telling our computer we want it to do a specific instruction using this translate method. We want to translate the position, we want to change the position of our vehicle using its transform property. Now, to tell the computer that we're trying to make it do a task, we need to use these parentheses. And a really handy thing that my IDE does, it is actually suggests different things that I can do and can autocomplete certain statements that I make if I'm trying to write code or if I'm trying to use a method. In this case, it's suggesting different things I can do with our transform.translate. So this here you can see inside of translate, there's a vector3 translation. So this is a parameter. This is a piece of information that I tell the computer to use to be able to do the thing that I want it to do. Now, I don't necessarily know what a vector3 is right now. So let's see if there's other options. You can see there's 6 total options. And this one seems to be really useful. So this one actually says that it will move the transform. It'll change that position by the X, by the Y, and by the Z. If you remember, I was trying to move my vehicle on the Z. So what I can do is, I don't want my vehicle to move in the X direction. I don't want it to move left or right, so I'll just type in 0. I don't want my vehicle to move up or down. It's not a plane or a spaceship, so that's also 0. But I do want to move it in the Z direction, so I'm going to make that 1. Now that we've added our parameters to our method and we have that closed parentheses, we actually now need to add a semicolon.
바꿔줘야 된다.
And so the semicolon actually tells your script that the method is now complete. So you can think of how we use periods to end our sentences and close our statements. When you're programming in C#, you use a semicolon at the end of your method to tell the script that this is the end of this line. So now what this will do is, update is called 50 to 60 times every second. So in a second, our vehicle will move 60 units, 60 meters in a certain direction. So now if I test this in Unity, when I press play, I should see nothing. Okay, that's not what we want to happen. Let's see. Get out of play mode. What did I do wrong? So let me just... Player controller. Oh, I forgot to save. So you can see in our project window, I selected our player controller script, and it looks exactly like how we left it when we first opened it. There was no information inside of it. But as you can see in our script here, we've added 2 lines in here. We've added a comment, and we've added this method that we created. So the problem is we didn't save. Simple as that. So if you just press Control or Command S, now our script is saved. You can see now in Unity, in our inspector for the preview of our script, we can see those lines of code now. So now when I press play, I should see the vehicle move. There it goes. It's speeding all the way off the runway. And it's flying off into space. Maybe it's a spaceship. Cool. So we've written our first line of code to move our vehicle. So what you're going to do is in your player controller script, underneath your update method, inside of your update method, underneath the comment, you're going to write transform.translate, and then you're going to use an open parentheses, type a 0, comma 0, comma 1, close parentheses, and then semicolon. Now it's your turn.
오케이. 더 다른 깔끔한 코딩 방법이 있다. 한번 보자.
Our vehicle now moves virtually at the speed of light, just flies straight down our screen. So that's good. We've got the movement in. Now I just want to highlight some things with coding to make our lives a little bit easier. So with our player controller script open in our IDE, my IDE does some really useful things to make my life a lot easier. So one of the big things first is if I start typing a word, say transform, it automatically tries to suggest the word that I'm trying to type, in this case transform, and I can press enter, and it'll complete that word for me. Now, if I type dot or period or full stop, you'll see that my IDE suggests all of these different words. And a lot of these words, especially if they have this little purple icon next to it, these are all actually other methods that I can use, just like our translate method. Now you might hear people say methods or functions in Unity and in C#. They're essentially the same thing, but a lot of people just tend to call things methods when you're using these kinds of statements here that have parentheses. Now, you can think of all of these different words very similar to how you would think of a dictionary. And so a dictionary helps you understand a word that you're looking for. In this case, in programming, this is called documentation. And so our documentation, or our dictionary, tells us all of the different words, all of the different actions that we can perform with our transform component here. So I'll use translate again. And now, if we push that dictionary analogy even further, so we have the word translate, and if I use an open parentheses, you'll see that now my IDE suggests different parameters, different pieces of information that I can tell it to use to do something. You can think of this very similar to a thesaurus and synonyms, where many different words have a similar meaning. In this case, we have many different kinds of methods, and these methods all have different ways that you can essentially do the same thing. So in this case, it's asking for a vector3 translation. Now, in order to get a vector3, I can actually just type vector3. And here, now, you can actually see, we actually have a suggestion as to what a vector3 is, which is super helpful. So my IDE tells me that a vector3 is a representation of 3D vectors and points. What does that mean? Well, in fact, that 0, 0, 1 is just 3 dimensions of points, 3 different points that we use, a 0, and a 1. In fact, that 0, and that 1 all correlate to the position on our transform component. So we have the 0 on the x, the 0 on the y, and then our 1 is actually the z updating over time. We even have these vectors, these 3D points, in our obstacle with our position. You can see the 0, 0, and the 25. That's a vector3. That's 3 different points that we're storing. So with that information, it's very helpful because we can actually just shorthand this bit of code that we wrote with 0, 0, 1. In fact, if we use dot and then forward, you can see that forward is actually just shorthand for writing 0, 0, 1. So that actually, can save us a lot of time, and especially is very helpful to making our code easier to understand. Because if I told a person to move something 0, 0, 1, they'd be like, I don't know what you're talking about. But if I tell them to move forward, they know the direction of forward. So this is how different keywords in programming can help make our lives easier, to make it easier to understand what is in front of us, but then also translate that into something that the computer can understand. In this case, the 0, 0, 1. So if we remove now our previous line of code, Now, we'll just make sure that we save. Always make sure you save before you go back into Unity. And now, in our player controller, you can see that our translate method has changed from 001 to this vector3 forward. And when I press play, our vehicle is still flying all the way off the screen. So, looks like our code did exactly what we wanted to do before, which is great. And it's easier to read. So what you're going to do in your player controller script, you're going to change your line of code from 001 to vector3 dot forward. Now it's your turn.
차량 속도를 바꾸는 방법.
We've fixed our vehicle, so now it flies down the screen once again, extremely fast. At least our code is a bit more readable, but now we need to slow that vehicle down so it doesn't just fly off into the distance. So in our player controller script, we're actually going to use a little bit of math in this method to be able to slow our vehicle down. So first what we're going to do is we're going to want to change the way that we move our vehicle. So currently the way this works is our update method is called every single frame. But depending on how powerful your computer is, you might get 20 frames in 1 second, you might get 60 frames in 1 second, and so really your player could move at varying speeds depending on what kind of device they're using. So we actually want to change that from updating every frame to updating over time every second. So the way that we do that first is by multiplying, and for a computer you should use the star symbol. So if you press shift on your 8 key, it'll create that star symbol, because actually if you press X and use the X key, it considers that an actual letter that it needs to know to use for a word. So we use the star symbol to tell us that we're multiplying something. And then what we'll actually do is we have a class already made to keep track of time, so we don't have to write a class ourselves. So that is called time with a capital T, and you can even see it highlights it in green. That way we know that this was a pre-made class. So now we're using time to keep track of our time, and we actually use delta time to get the change in time between all of our different frames. So now, using this bit of code, we can actually know when 1 second has actually elapsed versus 20 frames happening, 60 frames happening. Who knows? We can't control that. We can control how much time is actually passing. So if we go test this, we press play, and our vehicle is still flying down the road, and that's not what I want it to happen. I forgot to save again. Okay, so back in the player controller, just make sure you save, Control or Command S. That way it always updates the script in Unity. So now, when I press play, we should see our vehicle moving, albeit very slowly, but because of that little bit of code we added, we're actually now moving 1 meter a second. You can see, if you want to time it, it would probably be just about 1 unit every single second. So cool, now we have our vehicle moving by time. Granted, it's moving very slow, but we can fix that pretty easily. So what we're going to do in our player controller, we're just going to multiply by a random number using that star symbol. So we'll multiply by, say, 20. So it should move about 20 meters every second now. So now if I test and I press play, and I forgot to save again. Always remember to save. Now when we press play, there you go. Now it's moving nowhere near as fast as before, but definitely not as slow either, which is great. As a fun little tidbit, the way that this formula actually works, this little equation that we have, so in fact, vector3.forward is storing a 0, and a 1. And so when you're actually multiplying it by the time and by 20, you're actually multiplying each of the different values. So first you multiply your 0 by time and by 20, which will always be 0. Then you multiply your y, which is 0, by time and 20, which is still 0. And then you multiply the z by time and by 20, which gets you 20 meters a second. So just a fun way to kind of see how the math works, and would definitely save a lot more time than just typing 0 times time.delta time times 20, comma 0 times time.delta time times 20 times 1 times time.delta time times 20. So a really helpful way that, especially this shorthand, makes our lives even easier than before. So what you're going to do is, in your update method, you're going to change your transform.translate to just include a star symbol for multiply, and you're going to multiply your vector3.forward by time.delta time, and then you're going to multiply all of that by 20. So now it should move just about 20 meters a second, so that when you test your game, you press play. If you select the vehicle while it's moving, you can see the z value changing, and if you use the stopwatch, I'm sure you can see that it probably moves just about 20 times every second. So now it's your turn.
나왔다. 물리를 추가해보자.
Our vehicle now speeds along at a normal rate instead of incredibly fast or incredibly slow. And now we want it so that we, instead of just driving straight through this box, actually can collide with it. In order to simulate physics in our world, we actually need to add something to both our obstacle and our vehicle. And we'll do that using our components. So our component system can add a lot of different properties that people regularly use. In this case, a property that people will commonly use for physics is a rigid body. which is a physics concept, and in this case allows us to interact with this truck here that we have as if it had real simulated physics on it. So now it's a solid object. You can see that on the rigid body component in our inspector. It has a mass, so we can actually make this heavier. We can use gravity or we can not use gravity. So there's all these different options. In fact, I think our inspector is getting a little bit too crowded, so you can actually click on the little arrows next to all of the component names, and it will compress down each of the different options. So that's certainly very handy if you have a lot of different components. So now we can see our rigid body component, which is great. And then on our obstacle, we can also go, and with our obstacle selected in the inspector, we click Add Component. If we type in rigid body again, we can add another rigid body. So now our obstacle and our vehicle both have rigid bodies, which means they're both using physics.
해보자.
They both have mass, they both use gravity, so that's really helpful. And then one other important component to note in our list of components in our obstacle and our vehicle is actually these mesh colliders that we have on both of our objects. And our colliders are basically our ways of telling our simulated world that these objects can be collided with. So it knows that because there's a collider on this, when it runs into something like the ground or when it runs into something like our vehicle, it should do something like make it stop because we have a rigid body on it. So if we actually press play, you can see our vehicle collides with our crate, it goes flying off. If we were to turn any one of these things off, so for example on our obstacle, if we turn off our mesh collider, our box actually just flies straight through the ground, and that's because our mesh collider is telling our game world that the box no longer collides with our road, so therefore it can just fly straight through because it's not supposed to. You can see our vehicle collides with our crate, it goes flying off. If we were to turn any one of these things off, so for example on our obstacle, if we turn off our mesh
차량의 메시 콜라이더를 끄면 그래도 잘 박는데. 상자의 메시 콜라이더를 끄면
mesh collider, our box actually just flies straight through the ground, and that's because our mesh collider is telling our game world that the box no longer collides with our road, so therefore it can just fly straight through because it's not supposed to collide. So really fun things that you can do, and just to kind of make our little driving game simulation a bit more realistic, we're going to increase the masses of these two objects just to make it a bit more fun, make it interesting. So we'll make our obstacle, our little crate, maybe about 20 kilograms or so, and then the mass of our vehicles, I don't know, maybe something like 1,000. So now this has even more weight behind it, so when it hits that box, you see a slightly different effect happen. Yep, see, so it took much longer for that crate to fly over the vehicle because it was much heavier. So fun little things you can do to create better simulated worlds in your games using things like colliders to tell your objects to know when they've collided with something like our vehicle and our box, or even our box and our road, using rigid bodies to be able to create physics on our objects, so that way our obstacle actually has weight, our vehicle has weight, and we're using gravity, so it's actually being pushed down into the ground at all times. So what you're going to do is on your vehicle, you're going to select it in your hierarchy, and you're going to go into the inspector on the right side, click Add Component, and you're going to add a rigid body. And then the same thing you'll do with your obstacle, select it in the hierarchy, go to the inspector, click Add Component, and then make sure you either search for or select the rigid body component out of the list. So you can do that either by going to Add Component, going to Physics, and then you can see all of the different options like the rigid body, or you can just type in rigid body, and there it is, super easy. Now it's your turn.
메스 콜라이더는 조금 아직 이해가 조금 안 되긴 하네. 장애물을 복제해보자.
We've got some physics in our scene now, and we've got collisions happening, so as our vehicle is driving the road, it runs into this box goes flying, and now we're going to make this road just a little bit more treacherous, make our game a bit more difficult for our player by adding some more boxes. Make sure you pay attention before you do this yourself. Now what we're going to do is we're actually going to select the obstacle, and I'm just going to make this a little bit easier for myself, so I'm going to left click and drag the obstacle in our hierarchy and drag it all the way to the bottom of this list, so you see this little blue line underneath all of the other lists of objects. And if we let go, now you can see our obstacles there. And now what I want to do is I need more boxes in this scene, so I'm going to select the obstacle in the hierarchy by clicking on it, and I'm actually just going to press the Control key and the D key at the same time. So if I Control D on our obstacle, it immediately duplicates our obstacle, and now we have another. And you can see if I hover my mouse over the scene and I press F to focus, It's directly on top of the other box. So that's not what we want. But we'll just move this one a little bit farther back. We'll try and get it to around 50 or so. I'm just going to estimate. Yeah, around there is good. 50.1, almost had it. Now we have a second obstacle, but we want to add more. So if I just keep duplicating and dragging, that'll take a long time. So I can actually do something to make this a bit faster. So if I select my first obstacle and I control-click on my second obstacle, now if I Control-D, it creates 2 more obstacles. And in fact, I can move these back even further, just about, let's call it like there. That's good. We'll shift my perspective, so I'll actually click the little green Y in our scene view. Now we have a top-down view. And now I'm going to zoom out, so we're going to Alt and we're going to right-click and drag it to the side all the way to the left, so we zoom out even more. And now we can see, maybe a hand tool might be useful for this. So I press Q, select my hand tool, there you go, so you can see more of the road now. Actually, it might help if I just turn, there you go. And then just zoom in a little bit. Perfect, cool, now we can see our road even better. Really good opportunity to test out your movement skills and see if you can navigate your scene. So now we have our 2 boxes, now we're going to make another set. So now I'll select my first obstacle, and in fact, if I just hover over the last obstacle, I pressed Shift and left click at the same time. Now all 4 are highlighted. Now if I Control D to duplicate, I have 4 more obstacles. Now if I select my move tool, I can move all 4 obstacles down the line, somewhere like there. Cool. You can see this last obstacle, obstacle 7, is a little bit off the road, so we'll just delete that. So I'm just actually going to press the delete key on my keyboard, and it deletes it from the scene. So now we'll save really quick, and when I press play, you can see the vehicle drives, hits one of the boxes, 2, 3, 4, all the way down. You can see them tumbling down in the game view. So, up there the vehicle goes straight down. Oh no, can we catch it? No, it's gone forever. Well, we know the physics works now, so that's great. And we hit all the obstacles, and we've made even more, so we've made things just a bit more difficult. So what you're going to do is you're going to take your first obstacle, you're going to use Control-D to duplicate it, move it down the road, just using the Z-axis, this blue arrow on your move tool. And then you can actually select your first obstacle and control-click on your second obstacle. And then when you Control-D, it'll actually duplicate 2 more obstacles, so then you can move those down the line. And then you can actually just select your first obstacle and then shift-click on the latest obstacle you made to select all 4 obstacles, and you can drag those all the way down the line. And then you can test your game out. Now it's your turn. So we've made it to the end of this little lesson. To wrap everything up, we've added some really good functionality to our game now. So when I press play, see the vehicle drives down the road. It doesn't move incredibly fast. It moves at a nice normal speed. It runs into all these boxes with physics. Because the vehicle has physics, it just drives straight off the road, which is totally okay. Be free, vehicle. We also learned a lot about coding in this lesson. We created our very first C# script, learned a little bit about the structure of how scripts and classes work. We learned about comments, even made a few of our own, learned about methods. We wrote our very first line of code and called our first method to be able to move the vehicle forward. So now we know how to use methods. We've learned a bit about parameters and how we can pass computer the information that we need to do something. We even cleaned up the way our speed is calculated a lot by making sure that our vehicle moves over time instead of once every frame. And we even learned about these cool little multiply operators. And then
또 다음에 또 해야겠구만. 이렇게 해서 C# 스크립트 써서 움직이는 거 만들고 상자들도 복제해서 하는 거, 그 다음에 물리법칙 추가하고 부딪히는 거 만들고